Hello, welcome back. We're working on Chapter 6, Section 6, solving systems of linear inequalities. In this problem, we're going to be doing a business application. And I'm going to give you a little bit of background on this one. So the problem is based upon a surf shop, and they're going to sell surfboards and wakeboards. First thing I want to draw your attention to is that most stores sell something more than just two things. Okay, that'll be key. So this is already a more simplified problem than what the real world would say, right? And you're probably going to think about that and say, no, this seems complicated, and it's okay, you're learning how to do it. But again, I want you to just have in the back of your mind, what would happen if they sold something else? I'm sure they sell clothing, and they sell all kinds of other stuff that surfers would want, right? I've actually been in a Ron John's, and they had like 3 or 4 levels of stuff, so it gets a lot more complicated than this. The next thing that I want to mention though is that there's a really important reason why we're doing this, and this is getting you set up for something that you're going to learn about in Algebra 2 called linear programming. Linear programming is how we find, well, the word is called optimize. We want the best out of something, and sometimes we want something to be maximized. So if it's something good, we want the most of it. You can also do the same thing if you have something bad and you want the least of it, the smallest amount. That's called minimize. So this is setting you up for Algebra 2, trying to get you ready for doing those linear programming problems, and that's a big part of Algebra 2 Quarter 1 that we're going to be doing. So let me walk you through this step by step. Now I don't usually read these word for word. I like to stop and talk about it while I'm doing it, all right? So if you want to pause it and read it to yourself, that's fine. So I have a surf shop. Someplace that's near a beach someplace, and a store that's near a beach someplace. And this shop apparently sells surfboards and wakeboards. Okay? Now, the shop owner sells at least 10 surfboards each month and at least 20 wakeboards per month. Okay, that's information. I'm going to put that aside for a second. The shop owner wants to earn at least $2,000 a month off of surfboards and wakeboards. How do I know how much the owner is going to make or the store is going to make? It tells me that $150 from every surfboard is profit. That does not mean that each surfboard costs $150. That means that that's the amount of money that the owner gets to keep. The owner might, but probably doesn't, make his own surfboards. Probably buys it from a manufacturer. So part of the money goes toward that manufacturer. Even if the owner is like making his own in the shop, then there's also material supplies, there's labor, there's other costs. This is just how much profit the owner is going to make. With the wakeboards, everything's the same idea except it's $100. That's information we're going to need later. So, show and describe all possible combinations of surfboards and wakeboards that the store owner needs to sell to meet the owner's goals. And then we're going to give a couple of combinations there. We'll get to that in a minute. So what we need to do is we need to come up with a system of inequalities, because we're using words like at least, and everything's at least actually. So that means that's the smallest amount. It's better if you make more. He doesn't want to make less than $2,000. He wants to make at least $2,000, but more is better. So everything's going to be an inequality. But before I can do this, I have to figure out what my variables are. So the first step is to define the variables. I'm going to let, and I should use S and W for surfboard and wakeboard, but I'm going to use X and Y because if I graph this on Desmos, it doesn't understand what S and W are. It understands X and Y. And if I graph it using this, which I'm not going to, I have to use X and Y. So I'm going to let X, the letter X, represent, that's what that means, the number, I know that's a hashtag, but it actually is a symbol for number, the number of surfboards sold. And I'm going to let Y represent the number of wakeboards, again, sold. I didn't have room to write right here, sold. Okay, so let's make some inequalities. The first thing, the shop owner sells at least 10 surfboards. X represents surfboards. So X, the number of surfboards sold, has to be greater than or equal to 10. Now I know we get confused because you use the word least, that sounds like less than, why did I use a greater than? But use logic and think about it. The shop owner wants to sell a lot of product. That makes more money. So the shop owner wants to sell more than 10, but he'll be happy if he sells at least 10, which is equal to 10. So I'm going to graph this. The boundary line is going to be, and I'm going to try to squeeze it all in here. The boundary line is going to be x equals 10. That's a vertical line. It is going to be a solid line because it's the or equal. And because it's vertical, let me draw it first. Vertical solid line is going to look like this. And because it's vertical, I can't talk about it being above or below. But I can talk about it being, this is the only time we're ever going to talk about it being to the right or the left. I want numbers that are bigger than 10. So that's going to be over here. And I'm using my black marker right now. I'll switch to the other colors in a moment. I'm going to draw like this. All right. Now, we also find out that the shop owner wants at least 20 wakeboards. Okay, so the number of wakeboards is Y. 20 is okay, so it could be equal to 20, but more than 20 is better. So the number of wakeboards sold has to be greater than or equal to 20. So the boundary line is going to be, I got to change something, I'm sorry. I said it, but I didn't write it right. X equals 10, that's supposed to be a 10. I just noticed that out of the corner of my eye. My boundary line is going to be Y equals 20, and it's going to be solid. So Y equals 20 is right here. That's a horizontal line, and solid goes right here. And notice I did not go below it or to the left of it. That's because I can't have negative number of surfboards. So I got to start where it's positive. Got to start where it's positive. This one going this way, this one going that way. I want this to be more than 20, so I'm going to shade it like this. All right, so far so good. Now the last part, this is where it gets a little complicated. They want to make at least $2,000 a month, so that's going to be more than or equal to 2,000. I want $2,000 at the smallest amount. More than 2,000 is great, but how do I figure out how much profit you're going to make? Well, each surfboard makes $150 worth of profit. So one would be 150, two would be 300, four would be 450. What am I doing? I'm multiplying the number of surfboards that I sell by 150. How many surfboards am I going to sell? X. So that's 150 times X. The same idea. Wakeboards are 100. So that'd be one wakeboard 100, two of them would be 200, three of them would be 300, four of them would be 400, etc. How do I figure out how much money I'm going to make from wakeboards? I multiply 100 times how many I sell. So that's going to be 100 times Y. I guess I gave myself too much space. The boundary line is going to be 150X plus 100Y equals 2,000. Let's see if we can graph this. All right. Let's let Y equal 0, and I'm going to find the X-intercept. 2,000 divided by 150. Now you can do that by hand. I'm going to do it this way. 2,000 divided by 150. What do I get? 13. 13 is here, or 13.3. So I got, here's 10, 11, 12, 13, and 13.3 is about right there. Yep, We're fine. We're fine. We're good. I'm just checking to make sure I did this in the right place. Now, what about the y-intercept? If I let x equal 0, I get 2,000 divided by 100, and that's easy. That's just going to be 20, right? So that one is right here. And that boundary line is solid one more time. I'll just try to draw it without a ruler. And because I want to be more than 2,000, I'm going to be above this line, and it's going to be just like that. Now, the cool thing about this is that I actually have 3 boundary lines. I have more than 2, like I've been doing before. So this actually represents where, like, what the solution is going to be. I'm checking something, and there's a problem with what's in the book, but that's okay. All right. So it turns out that this area right here where all of them are shaded, that's going to be where the overlap is. And then all you gotta do is just pick 2 points that are in there and figure out what it would be. Okay, we'll see you in the next video.